Let's continue talking about the edge of field studies. Again, this is Harold Waters, OSU Extension, talking about the fertilizer certification training programs we have. So, first of all, want to thank all of our supporters. We have very broad support for these edge of field studies, and the edge of field studies really get us down to the field level to see what's coming off the field. We try and eliminate, what the city may be doing, home septic systems, those other sources that we don't necessarily control, but let's get down to the involvement of agriculture. So again, we support or very strongly thank our supporting funders and partners on this, including USD ARS, the Field of Faucet program with OSU, Beck's Hybrids, Mississippi River Basin Initiative, and especially the growers of Ohio who are involved through the associations, the Ohio Corn and Wheat Growers and the Ohio Soybean Council. So what's the edge of field studies look like? We have 20 sites across Ohio. They're typical Ohio growing conditions by soil type, by soil test, by tillage. We have a mixture of tillage there as well. And then our goal is to initially monitor through a full crop rotation cycle, so corn, soybean for the most part, but corn, soybean, wheat as well. And that will give us a baseline to kind of measure things going forward. We will be collecting information for both nitrogen and phosphorus. With phosphorus, because of the Lake Erie concern, is a little higher priority, but we are definitely interested in collecting nitrogen information too. So this is what it looks like. Here's just an overshot satellite view of two fields, field 1, field 2 there, and you can see down in the lower right-hand corner of both sites, we have both a surface collection point and a tile collection point. Again, just an overview there. And this is what it looks like actually at the field level. So this is the monitoring house, stores the equipment, and you can see here that we're collecting the tile information here with that little line going down to the tile outlet. This is what the actually collecting information or collecting mechanism is that sits in that storage house, and we have capability of collecting 24 hours a day, 7 days a week, 365 days a year, and then on a regular basis, collect the information. The samples are collected and then tested. And then this is that surface weir showing just with here this slight slope in the field, showing that we can collect surface water as well, just so we can distinguish between surface and tile movement off away from the fields. A little bit about understanding phosphorus in water. There's two components of phosphorus in water, the sediment-bound particulate nutrients, and then also the soluble, what we call dissolved reactive phosphorus or just soluble phosphorus. And you can see here in the picture that from the picture on the right and the of the two shots here, that brown stuff that we'd see in a stream is the sediment-bound phosphorus, but also the clear liquid. You see there in the flask on the right, that would be the dissolved phosphorus, and we can measure that as well. Two forms have different activity in the water, different availability as far as phosphorus for growing plants. The particulate form of phosphorus has a bioavailability of perhaps 30%, and so we tend to get slow algae growth from that kind of phosphorus until it comes out in solution. And then the soluble phosphorus, that dissolved reactive phosphorus, 100% bioavailable. We get very much quicker growth from that form of phosphorus. Just an overview here real quickly, but our fertilizer sources do contain water-soluble phosphorus for the most part. You can see here that for most of our commercially available granular fertilizers, actually liquid and granular fertilizers, we're 85 to 100% water-soluble phosphorus, which is what we want. I mean, that's what the manufacturers deliver. We want phosphorus that is readily available for plant growth. Manure there, and I have several sources on that. Probably 50 to 80%, depending on how old it is, what livestock its species it is, things like that. But it's fairly high water solubility as well. Just some edge of field studies here. This is actually a summary across the 1 to 3 years, so depending on which site it is, where we are in the cycle. The dissolved reactive phosphorus, that DRP there on the left in the shot, shows that we are pretty much above that red line. The red line is somewhat our goal for where we'd like to see the phosphorus levels below that point. And you can see that we do tend to run above that for the study so far. Total phosphorus on the right, That would be both the sediment-bound phosphorus and the water-soluble. And so, yes, even here we're running above what we would hope. And then just a little better, broader overview on across the various sites. As I said, we're headed toward 20 sites collection. Some were just added in 2015, so we're not yet a full year study. But you can see here that, let's just take a look at the top chart there, dissolved reactive phosphorus. We have some fairly high levels come from fields, and those two fields you see, both the top and bottom charts, were historically livestock operations, so fairly high soil test phosphorus in those two sites. And then nitrogen, this is my last slide. Nitrogen, we're also collecting information too, and here we put it in terms of kilograms per hectare per year of nitrogen, but you can see on a, I guess, conversion basis, there's still well over 100 pounds of nitrogen loss we have experienced at some of these sites. Average here be 25 to 30 pounds of nitrogen loss per year. It's still a significant number and still a contribution to that growth of algae in Lake Erie.